The HEX2OCT function within Excel allows us to convert a hexadecimal number to an octal number. There are two arguments we can supply to this function. The first one being the number, so that would represent the hexadecimal number. And then there's an optional second argument. This argument is called places and defines if we need to add any preceding zeros to the new number. So let's give an example. Here we have the hexadecimal number that represents 1000. Let's convert this into the octal number system using the HEX2OCT function. I open the parentheses, I select the hexadecimal number, and I close the parentheses. You can see that the number 1000 is represented by the number 1750 and the octal number system. Now there is also the optional argument of adding places. So let's say I want the octal number always to contain 6 characters, then I put a 6 as a second argument for places. I press enter and you can see 2 preceding zeros were added, so now my entire octal number consists out of 6 characters, just like I specified in the places argument. Now let's fill out this table, so I double click in the right hand corner and here we can see the answer. Now you can see all of these numbers actually consist out of 6 characters, but these negative numbers, they cannot be represented with 6 characters, so then the second argument is being ignored. Now how exactly do these hexadecimal and octal number systems work? Well, in a regular decimal number system, we have 10 possible digits from 0 to 9. In these alternative number systems, such as the hexadecimal number system and the octal number system, we change the number of digits that are available to represent a number. So for the hexadecimal number system, we will actually be adding digits. So it goes from 0, 1, all the way up until 9. And then normally this would be it in a regular number system, but with the hexadecimal number system, we add an A, a B, a C, a D, a E, and an F. So in total, there are 16 possibilities. 0 to 9 represent their own number, but then once we get to the letters A up until F, they represent the numbers from 10 till 15. So in total, there are 16 different possible digits that can be used in a hexadecimal number system. Let's say we have the number 135. So that would be a 1, a 3, and a 5. Now, the position of these digits within the number determines their weight. Now, in a decimal number system, the 5, well, that we will be counting as 5 ones. The 3, we will be counting that as 3 tens. And the 1 we'll be counting as 100. Now we multiply the digits with their weight, so we do 1 times 100, and we do the same for all of the other digits. So we have 100, 30, and 5, and now we add all of these together, and we will get the result being 135. This is how the decimal number system works. Now let's try and recreate this for the hexadecimal number system. Now, 135 within the hexadecimal number system is represented with 87. Now, how does this work? Well, here the 7 also has a weight of 1, just like we normally would have, but the 8 actually has a weight of 16 because there are 16 different possible digits. Just like before, here we had a weight of 10 because there were 10 possible digits. So we put a 16 here. Now we multiply the digits with their weight, so 8 times 16 and 7 times 1. We add these together and we get the number 135. So far so good, but how does this work when we introduce the letters that come within the hexadecimal number system? Well, let's take a look what the number 2BE in hexadecimal would be in decimal. So let's get rid of this and write 2B and E. Now, since in Excel we can only calculate with the decimal number system, we will have to convert these hexadecimal digits to their decimal counterpart. Now, 2, that simply remains 2, so we take 2. B, well, this is equal to 11, so we will write 11 there. And E is equal to 14, so we write 14 there. Now, the weight of the position in a hexadecimal number system is 1 for the first digit, 16 for the second one, and 16 times 16 for the next one, being 265. Okay, so now we do just like before, we multiply the weight with the number. So we have 2 times 265, 11 times 16, and 14 times 1. Now we add all these numbers together, so sum, and we get the final result 702. So the number 702 equals 2BE in hexadecimal notation. Now the octal number system works in a similar fashion, but we are only working with 8 possible digits from 0 to 7. So that makes things a little bit easier. Now let's have a look at the number 135 in octal number notation. That would actually be 207. So let's try this out. 2, 0, and 7. Now, once again, the weight of the first digit equals 1, but the weight of the second digit will not be 10 like in the decimal number notation, and will also not be 16 like in the hexadecimal notation. It will actually be 8. So then for the third digit, that will be 8 times 8, being 64. Now we multiply the digit with its weight, so 2 times 64. We pull this through and we add the numbers together. So we sum all of this and we get the result 135. So the number 135 represented in octal number notation would be 207. So the Excel function HEX2OCT allows us to transform a hexadecimal number into an octal number. Now, if you still remember, the hexadecimal number for 135 was 87. So if we now use a function HEX2OCT, we can convert the hexadecimal 87 to the octal counterpart. So let's see what this gives. It's 207, exactly what we had here, because 207 represented 135 in octal notation. Now, one thing that you might have noticed is that something strange happens when we move into negative numbers. So you can see then the hexadecimal and the octal notation become really large. And this is because for negative numbers, we actually start all the way at the maximum value. So the maximum value for the octal number is this number, and for the hexadecimal number, it would be this number. And so that represents -1. Now for each number that is lower, we actually decrease 1 from the maximum. And so this is how negative numbers are represented in these alternative number systems, such as the hexadecimal and octal number system.